5, we're going to be solving a lot of word problems, okay? So word problems that will be involving quadratics, rational equations, and, charts and things. So this will be a good way to wrap up our chapter on fractions with some application. So take about 3-4 minutes, and we'll go over this. If I got anybody outside waiting. We had the ACT in here on Saturday, by the way, so if your desk is a little bit askew, make sure you're in the spot that you need to be in. Good morning. Come on, bud. We're doing our little warm-up activity. It's on the screen. You can get started. You might not have as much time as everybody else, but at least get a little bit done. All right, take about another 2 minutes. 2 minutes, and we'll wrap this up. You may not be finished. Keep working if you're not finished yet, but I reckon everybody's had a chance to do number 1. So we'll start with Will Edwards. What'd you do to get the ball rolling on number 1? All right, so you got 2n minus 2 minus 4 equals 10. And then? All right, so negative 6. Add 6 to both sides. Oh, it was negative 10. Thank you. Somebody yelled that out. Let's see here. Negative 10. Negative 10. So you add 6 to both sides, you get negative 4. So n equals negative 2. Something like that. Well. All right, fabulous. Pretty straightforward. Easy enough. Linear equation, one solution. Okay. We're going to skip over the word problem for right now. We're going to look at number 3. There's a couple different ways you can solve number 3. All right, you got x over 3 and x over 4, which are both, like terms, if you will. So 1/3 x plus 1/4 x. You could get a common denominator of 12, and so you could say, okay, that's 4/12 and 3/12, so that's 7/12 x, and then have your proportion and cross multiply. You could definitely work it that way. James, what way did I recommend you work this kind of equation? And I'll remind you, we talked about first-person shooter video game and a frag grenade. Remember talking about that at all? Oh, in the video. Hey, James, you look like you might be drawing a blank. What about you, Joe? Any ideas? Somebody tell me, how can I kill all these fractions off? Yeah, we're going to multiply everything by 12. Multiply the entire left side by 12. Multiply the entire right side by 12. And it may be that some of y'all haven't got to number 3 yet if you were working these in order, and that's fine. But really what we're doing is we're multiplying 12 on the top of each and every fraction. Now, not so that I can actually do that multiplication, but so that I can cancel each denominator, kill all the denominators all at once, okay? 12 over 3 cancels down to 4, so it leaves me with 4 times 1 times x. 12 over 4 leaves me with 3 times 1 times x. And 12 over 6 is 2 times 5. And so I've got 7x equals 10, or x equals 10/7. Okay. The other way that I had talked about maybe working this one was like if you wanted to combine the two fractions, right? Here, I'll just zoom in this way. If you had wanted to change the first fraction, to 4x over 12, and the other fraction to 3x over 12, and combine those two together to get 7x over 12, and then the right-hand side being 5 over 6, you could cross multiply and solve it out. You get 60 equals 35x, and divide both sides by 35. 60 over 35 equals x. Of course, you would want to simplify that out, dividing both of those by what? Divide by 5, and you get, well, I'm not going to get the same daggone thing. What did I do to mess up? Well, if you divide 60 by 5, you get 12. And if you divide 35 by 5, you get 7. So I've done something wrong. Y'all help me figure out where.
The 7x and 6 would be 42.
Thank you. See, I need a little warm up today too, don't I? 42x. That makes it much better. Because now they're going to have, instead of a 5 in common, they'll have a 6 in common, which makes that numerator going to be 10. Much better. Anyway, I recommend doing it the blue way. The blue way is a little bit more efficient, especially when you start having some polynomial denominators. And we saw that a lot in the last section. So as far as warm-up goes, we had an easy linear equation. We had an equation, a rational equation with fractions, right? What about the word problem here? What's the background formula that we have in our mind, Joey? Or a piece of prior knowledge, talking about speed and talking about distance. Oh, come on, it's as easy as dirt. Luke, help him out. Not distance times rate times time. When I say it's as easy as dirt, attaboy. D-E-R-T, distance equals rate times time, okay? Now, distance equals rate times time is sort of the background knowledge that I have to have coming into this problem. Okay, I also like to consider a drawing. It said the express train can do the trip in 2 hours. So the express train's leaving Chicago and traveling towards Champaign, Illinois, wherever Champaign is. I don't know if it's east of there, but I'm just drawing it to the right. It says the express train can make the trip in 2 hours, and the bus is going to make the trip in 5 hours. So in other words, if I consider, let's just say this is the express train, and up here, this is the bus. What do I know about those two vehicles? They're doing what? They're going to the same place, and therefore what is equal? Their distances are equal. Very good. So if I can come up with an expression that relates the distance of the bus equal to the distance of the train, then I've got myself the equation. And remember, writing a word problem, the hardest part is coming up with the equation. Okay? Coming up with the equation. So if the distance of the bus is going to be the rate of the bus times the time of the bus, and the distance of the train, similarly, is going to be the rate of the train, or the speed, times the time of the train. So all we need to do is just equate those two distances. Now, I've taught you also you could come up with a chart. Some of you guys like the chart approach. So we got rate times time equals distance. And you've got the train and you got the bus, right? And you can organize your info. This is nothing new. You guys know this, right? And you can start plugging in the information. Well, let's see. It says the express train can make the trip in 2 hours. So that's the time of the train. It says it takes the bus 5 hours. That's the time of the bus. The average speed of the express train is 42 faster than the bus. So if I let the bus be x, this one's going to be x plus 42. And then I multiply from left to right. Okay, so 2x plus 84 is the distance that the train goes. 5x is the distance that the bus goes. And we just set those two equal and solve, right? So when I set these two equal, 2x plus 84 equals 5x. I'll subtract 2x and divide by 3. X equals 84 divided by 3. Somebody tell me quick. Louder. 28. All right, so the bus goes 28 miles an hour. And so it says find the average speed of the bus, so that's what we found. What if it said find the average speed of the train? What would the train be? Yeah, 28 plus 42, right? So you want to make sure you answer the question appropriately. You'd say the bus goes 28 miles per hour on the average. Okay, that'd be a long trip doing that in 5 hours. Whew. Go ahead. X plus 42, so 28 plus 42 would be 70. All right, any questions on the warm-up? I know today's a Monday morning, and so sometimes I got to get the blood flowing, got to get my brain working, right? Any questions on what we just talked about? Okay. It's helpful to know some background knowledge like dirt. It's also helpful to be mechanically solid when we're solving basic equations. We're going to start example 1 talking again about a proportion, okay? I don't know if you guys could read this, but we're just going to do a buttload of word problems today in class. And so get ready for it. Now it says pediatrician is prescribing acetaminophen. What's acetaminophen frequently called? There you go, that boy, Tylenol. So it's going to prescribe some Tylenol to children. They prescribe 5 milliliters for every 25 pounds of the child's weight, okay? That right there is a ratio, a comparison of two things, okay? So 5 milliliters for every 25 pounds, okay? That's a basic ratio. Now, right off the bat, Reed, what could I do to that ratio? Yeah, I could just say, oh, well, that's easy. That's 1 milliliter for every 5 pounds that kid is. Now, that technically they don't do it that way. But, you know, it goes in increments of 5 if you look at the back of the medication for like infant Tylenol or Motrin or anything. But in this case, it says Zoe weighs 80 pounds. How many milliliters acetaminophen should her doctor prescribe her? So if I've got this unknown quantity of milliliters that I'm trying to figure out, and I know she weighs 80 pounds, okay, right here, this is what is called a what? A proportion. And how do I go about, Charlie, solving a proportion? Yeah, buddy, it's where we channel our inner fruit ninja. Cross multiply, right? We talked about this. So I multiply 1 times 80, multiply my unknown, you just call it x if you want to, x times 5. We're going to end up dividing by 5. So what is that, 16? 80 divided by 5 is 16. So we wind up with, she's going to need 16 milliliters being an 80-pound child. Again, I don't think they do it that way in the real world. It's usually in increments of 5, but there you go, what have you. Okay? Setting up a proportion is very, very applicable in the everyday life. Okay? I think I used the example of muffins last week. Did I talk about muffins last week? In one of the videos, I think I did. You guys that haven't watched the videos, shame on you still. But you know, like if I were to say I was going to bake y'all some muffins one day, if we weren't in COVID, I'd be baking you some either blueberry muffins or chocolate chip muffins, right? What kind do y'all prefer? Ooh, I heard a lot of blueberries. A couple of chocolate guys. You know, oddly enough, those are my two favorite kinds of muffins, but they do not mix well. One time I did both in one batch. I made like blueberry chocolate chip muffins. They were terrible. Okay, which is very surprising. But anywho, like if my normal recipe calls for 3/4 cups of milk, okay, to make a dozen blueberry muffins, I need to make more than a dozen blueberry muffins. I need to make about 30 blueberry muffins for this group, okay? Because I'd give one to everybody in here and then I'd eat the rest. Yeah, sorry, Lewis, you're out of luck. The idea though is what? I just set up a proportion, just like we did right there. Out of a proportion, how many parts are there? Check. Yeah, there's 4. There's 4. There's the extremes, which is the top left and the bottom right from your point of view. And there's the means, which is the bottom left and the top right. Okay, those are good words to know. The extremes get multiplied, the means get multiplied, and then you set those two products equal to each other. That's how you solve a proportion, cross multiplying. Okay, and out of those 4 that Jack mentioned, usually you'll know 3 of them, which makes for an easy proportion. Okay, recommendation from good old Coach Morgan here. It's easier if the unknown is up top. Okay, I'll give you a for instance, and this is not a trigonometry class, but you guys can handle some trigonometry. There's this thing called the law of sines that you'll learn in trigonometry one day. Whereby if you have a right triangle, okay, and you call this angle A, this angle B, and this angle C. I don't see anybody writing things down. This would be a neat thing to write down, right? The sine of angle A is just the ratio of the opposite side over the hypotenuse, okay? For instance, you guys don't know that yet, do you? Y'all ever learned anything about SOHCAHTOA, sine, cosine, tangent, all that stuff? No, well, you will one day. Anywho, the way that it works is that you have this proportion, okay? And oftentimes I'll tell like my juniors or seniors that are taking some trig stuff, I'll say, look, you can flip both sides of that proportion and you can come up with another equivalent equation. And I tell them just exactly what I told y'all. I say, look, if you've got out of those 4 parameters, if you know 3 of them, just arrange it such that your unknown is up top. That makes it so much easier. Okay, so like for example, they might have in one of their problems, they might know little a, they might know big A, and they might know little b. Okay, and I might be asking them, hey, solve for the angle B. Okay, so like they might know that I don't know, little a is 10. The angle A is 32 degrees, and they might know that the side B is 14.5, and they might be trying to figure out what is angle B. So that's their unknown. And what I tell them is just write the proportion up using the approach where your unknown is at the top. You can flip both sides of a proportion. That's the lesson I'm trying to show you guys as 8th graders, is that you could instead of having your unknown at the bottom, you could very simply write this as sine of 32 over 10 equals the sine of B over 14.5. And then instead of going to the trouble of cross multiplying and creating 2 more steps, because look, if I cross multiply, that's a number. Sine of 32 times 14.5, that's some number, right? And then 10 times sine of B, I'm going to have to divide by 10 on the next step. Instead of doing that, watch what I could do. I could just simply multiply both sides by 14.5. and I get my value, my variable by itself, okay? So instead of cross multiplying, sometimes it's more advantageous just to multiply by the denominator of the side that's got your variable in it. Like over here, back where we were dealing with the medication, right? If I just had this as X, and we'll simplify this out, we'll get rid of all the units. Okay? With my unknown being up top, all I really have to do to both sides, instead of cross multiplying and then dividing, all I really have to do to both sides is what? Multiply by 80. And I leave the X alone by itself, and whatever I do on the left, I do on the right, and then there you go. I got 80 over 5, or 16, whatever that was. Okay? So make a mental note, or actually write it down, that with a proportion, to solve it, you cross multiply, but you can be more efficient, and if you set it up to where your variable is at the top, and the reason I'm hampering you on this, fellas, is because you're going to do a lot of proportions next year in geometry. You know what I mean? You're going to be doing a lot, Paul, pull your mask up. You're going to be doing a lot of proportions in geometry, and you're going to want to be savvy about how you solve those proportions. Put the variable or the unknown up top, and then you can just multiply both sides by the denominator of that fraction. Okay? Now, I mentioned geometry. One of the things that you guys deal with in a geometry class is going to be triangles. Okay? You're going to be dealing a lot with triangles. A picture that I've got drawn up on the screen right here, it's a very artistic picture, thank you so much, is a rendering of similar triangles, quote, quote, similar triangles. Write that phrase down. Similar triangles allow you to write all different kinds of proportions, okay? Proportions, again, are a way of showing equivalent ratios, okay? So, for example, I got this blue stick figure guy. His name is Tyler. Hello, Tyler. And he's 6 feet tall. And then his shadow is 8 feet long at a particular time in the afternoon, you know, where the sun's shining down. I got my orange sun and all that good stuff. So Tyler is 6 feet tall. I don't know what that was all about. So Tyler is 6 feet tall, and he casts an 8 foot long shadow. Okay? And it says at the same time, the shadow of the tree is 24 feet long. I know my drawing's not to scale, but you can deal with it. 24 feet long, and we want to figure out how tall the tree is. So the way to solve this is to understand how to set up a proportion. Now you can set up with similar triangles, which these two guys are similar triangles. You can set up any kind of proportion that you want. You could say big triangle left side compared to big triangle bottom is equal to small triangle left side compared to small triangle bottom, right? So we could write up a proportion that looks like that. We could say X over 24 equals 6 over 8. We could do left side compared to left side and bottom side compared to bottom side. So I could say, all right, left side of the big triangle is X, left side of the little triangle is 6, bottom side of the big triangle is 24, and bottom side of the little triangle is 8. So we could write it up like that, okay? Notice both of these have my variable where? Up top. That's a smart way to write out your proportions, as we just mentioned, okay? Here's what I could not do, and I'll put this in a different color. I can't mix them. I can't say like left side of the big triangle compared to left side of the little triangle. I can't say X over 6 and then say bottom side of the little triangle compared to bottom side of the big triangle. Why can't I do that? Why can't I say X over 6 and 8 over 24? I mixed them. I broke the equality of the ratios. You see, a ratio is a comparison of things. On this left side fraction, I'm comparing big to little. On the right side fraction, I was doing little to big. It don't work that way, okay? What are those things called when you're in elementary school and you're like, Coach Morgan is to math teaching as Tom Brady is to quarterbacking? Okay, you can just use a silly, vain example there. What are those called? You know what I'm saying? It's called an analogy, isn't it? Right? So like you wouldn't mix the two analogies. You wouldn't say, again, just being a little vain and silly here, you wouldn't say Coach Morgan is to math teaching as football is to Tom Brady. Right? That doesn't make any sense. So you have to, with proportions, you want the top and the bottom to be similarly structured. Okay? And by the way, has anybody actually solved this out for us yet? What did we get? 18? Everybody agree with that? Tree is 18 feet tall? Fabulous. Okay? So again, we see that the hard part of a word problem isn't necessarily solving the equation. It's doing what? Yeah, it's coming up with the equation, writing out the equation. Okay? And again, y'all going to do a bunch of proportion, similar triangle kind of questions next year in geometry. Example 3 is another dirt problem. We had one in the warm-up, so this should not be anything super challenging. Okay? But it says an airplane's going 200 miles into a 30-mile-an-hour headwind. Okay, let's stop right there and unpack that. George, is a headwind going to speed me up or slow me down? Very good. Y'all remember talking about headwind and tailwind? A headwind is going to subtract from my airspeed. Okay? A tailwind, whoosh, is going to add to my airspeed. So if I'm a plane and I can normally fly 200 miles an hour, but I got a 30-mile-an-hour headwind, how fast is my ground speed? How fast am I going relative to someone standing on the ground with a radar gun? I'm going 170. Very good. Okay? And it says in the same amount of time it takes to fly 300 miles with a 30-mile-an-hour tailwind. And it says, what is the speed of the airplane? So I like going to a problem and reading the last sentence first. Oftentimes that tips me off as to what my unknowns should be. Okay? So I'm going to say let x equal the plane's, oh, I misspelled plane. Plane's airspeed. Okay. So his rate going against the wind is going to be x minus 30, and his rate going with the wind is going to be what? Good. X plus 30. Okay. It says in the same amount of time that it takes to fly 300 miles. Okay. So I know all the distances, 200, and the time is, and the other distance is 300. Okay. But right now we're at a little bit of a quandary, or at least I'm pretending like we are. Okay. Because we aren't given any info about time. It just says the same amount of time. So what should I do here? What are your ideas? Mossy. Set the times equal to each other. Fabulous idea. How do I get with dirt? How do I get T by itself? Jack. Very good. Okay, so over here, think about dirt. If I've got D equals RT and I divide both sides by R, I produce an equivalent equation, T equals D over R. And therefore, the time of the first part of the trip, I guess going against the wind, would be 200 over x minus 30. Let's write that down. 200 over x minus 30. That's the time going against the wind. The time going with the wind will be 300 over x plus 30. And there we go. Lo and behold, we've written ourselves out an equation. Fabulous answer there, Mossy. Another way, by the way, another way to have worked this problem would have been to introduce a second variable. Now, brown cow. Do you remember solving systems of equations? What are our 3 techniques for solving systems of equations? We learned this in the first semester. Go. Elimination. Oh, I just flipped y'all the bird. Sorry. Whoops. I think I got that on film too. Elimination. Substitution. And graphing. Okay, probably wouldn't do graphing in this case, right? But if we had said, hey, let y be the times, right? we could have written up a system of equations. I'll do this down in blue. We could have written up, let y be the time, and we'd say, here, I'll zoom in for you guys. We'd say, okay, well, x minus 30 times y equals 200, and x plus 30 times y equals 300. And again, that would be a system of equations that I probably would solve using substitution. I would divide both sides by the parentheses, get y equals 200 over this, and y equals 300 over that. And then I would just say, oh, well, if y equals this and y equals that, then this and that must equal. And therefore, we'd get our green proportion yet again. Okay? Has anybody already solved this proportion out? Some of you alpha dogs in the house have been rolling with it. Jack, what'd you get? 150 miles per hour. What'd you get for, actually, no, I didn't want to know y. I wanted to know x. Good, good, good. Has anybody else done it? Anybody concur with that? Y'all not sure just yet? What we would do is we would cross multiply, right? 300 times x minus 30 equals 200 times x plus 30. Divide both sides by 100. Distribute. We get 3x minus 90 equals 2x plus 60. Subtract 2x, we get x. Add 90, we get 150. And there she goes. We're out of time for today, boys. We've been having too much fun and time has gotten away from us. But hey, we'll pick up with some more of these examples tomorrow in class. All right. And again, I know that you might not enjoy working word problems, but they are the cat's meow as far as checking to see if we really understand what we're learning and how to do it. Lewis Thomas, I'm going to cut you loose. Live Jesus in our hearts forever. Paul, how did I get what?